Welcome back to the channel. So today we will be solving this Python interview question, and it is very important interview question because this you can see in a lot of interview. So this was asked in Apple. So basically, if you see here, this blog was updated recently, right? And this is the problem basically. So given a list of numeric element, write an optimized code to shift all zeros to the end without using any extra space. So basically, if you see here, this is the input array where here we have some zeros and some non-zero values. And in the output, what we need all the zeros should be at the end of the array and non-zero value at the beginning, right? And there is other version of the same problem where we need all the zeros at the beginning of the array and the non-zero value at the end of the array. So like I will be writing the optimized code for this problem, and by changing just a single line, it will convert into a problem where we need all the zeros at the beginning of the arrays and the non-zero value at the end of the array, right? So let's see how we can solve this problem. The most important thing over here is we don't have to use any extra space, right? So we need to write the optimized code. But as I always say, before writing the optimized code, we should always try to solve the same problem using the brute force approach, right? Because we do some tweaks in the brute force approach to make it as the optimized approach, right? So let's start. So here we have been given this input array. Let me take a pen. So this is the input array basically, and here we have the output array. Let's see the number of elements. So if you see 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total we have 11. So the length is 11, right? And in the output also we need length 11. So all the non-zero values should be at the end of the array. Sorry, zeros should be at the end of the array and non-zeros at the beginning of the array. So these are non-zeros, right? So let's begin with the brute force approach. So what we can do in the brute force approach basically, uh, like in the optimized approach, we need to do this in place. So what what is the meaning of basically in place? That means we don't have to use any extra space, like the space complexity should be 1, and we need to just modify the existing array, basically this A array, right? So in the brute force approach, what we will do, we will use extra space. We will use extra space of O of n. So basically this, let's say the length of this array is n, then it would be O of n, right? So, okay, let's proceed with the solution. Before proceeding, let me write the array over here so that I can explain you the algorithm. So here we can write 1, 2, 0, 4, minus 1, 5, 6, 0, 0, 7, 0. Okay. So in order to solve this problem, what we can do, in brute force approach, there are multiple ways to solve this problem. So one of the ways, let me write way one in the brute force. So what we can do, steps can be, we can create an extra array of size 1, right? We can create extra array of size 1 and initialize all the values with 0. So we can write like this 0 comma 0 comma 0 comma 0, and this will be 0 of length 11. So the all the values are 0. And then the second step, what we can do, we can iterate the array A and put all the non-zero values at the beginning, right? So this we can do, and by default in the third step, like all the zero value would be at the end of the array. So zero values would be at the end of the array, right? So this would be the by default. Why? Because since we are like initializing the array with 0, right? So let's see. Let me write the piece of code, like how the code would look like. So we can write answer. So this would be our answer, and we can write as length of a. So this will create an array like this 0 comma 0 comma 0 and till the length basically. Okay, so the next step would be we can have a pointer, basically the helper pointer that will start with 0, and this will help us putting the non-zero values at the beginning of the array. So the next step, what we can do, we can write for val in a. So this will like bring all the values, and what we can do, we can just check if val is not equal to 0, then we just need to put at answer of helper val, and we can just do helper plus 1, right? And once this for loop ends, we will have our answer, right? So this is basically the simple solution. So let me iterate it through. So let's take another example basically of having of length of lesser uh, range. So we can write 1 0 1 2 4 5, right? And let's see. So here, like what it will do, first we will create an answer variable, and so variable there we will have all the values as 0. So here 3 2 5, total we have 5 elements, right? All would be 0, and then we'll iterate through this array. So 0 1 2 3 4, and what we will do, so this value will check if this value is 0 or not. So this is not equal to 0, so we'll put like 1 over here, and helper, since it was at here initially, it will come to here. Again this will check, is it equal to 0? Yes, it is 0. So we'll not do anything. We'll come over here. Is it equal to 0? No, it is not equal to 0. So we'll put 1 over here, and we'll increase the helper pointer. Again, this is not equal to 0. We'll put 2. Again here, this is not equal to 0. We'll put 5, and 0 would be there at the end. And once the like execution ends, we will have the values like 1 1 2 5 0. So this should be our answer, right? So if we talk about the space complexity and time complexity, so space complexity would be O of n, right? And time complexity would also be O of n. Why? Because we are iterating through the array once, right? So let me show you the piece of code and its execution basically. So now if you see here, the same thing, right? The code which I wrote over there, and if we run this, we are getting what we need. So now it's time to come to the like the optimized approach, that is without using any extra space. So let me explain you what we can do in that. So here we'll talk about the optimized code, optimized approach, right? So here if we take an array, let's say if we take the same example 1 0 1 2 5, right? So basically, if you remember in the like the brute force approach, this helper pointer, this helper pointer was only moving when this value was not 0, right? And we were updating the array, like the extra array which we were using, right? So can we do the same thing in the same array? So let me write the piece of code for the optimized code. So we can write helper equal to 0. So this value will only, let me write over here, will only move when we have non-zero values. Why? Because the task of this problem itself is bring non-zero value at the beginning, right? Bring non-zero value. So this should be always moving when there is non-zero value, right? So what we can do, we can write the code like this. So the same thing. So for I in range, and since here we are swapping the value, so I'm using like that this way, length of a, and then we can write if a of I is not equal to 0. So when it is not equal to 0, what we need to do, we need to just swap the value of I and helper. Got it? We just need to swap the value. So we can write swap I comma helper, right? And once the value is swapped and we have non-zero value at the helper index, then we can just increase the helper plus equal to 1. So this is the code basically, right? So let me iterate it through it. So we can write array equal to 1 0 1 2 5, right? 0 1 2 3 4. So we can have index like this. So this will be I and this will be H. So is it equal to 0? Is it equal to 0? Uh, so the condition is this value is not equal to 0? Yes, it is not equal to 0. So what we'll do, we'll swap I and H. So since they both are at the same index, so there will not be any changes. So it shows that we will increase both the pointers. So I would come over here, H will come over here. Is this value like a of 0 is a of 1 is not equal to 0? No, that's not the case, right? It is 0. So what will happen? The code will not come in this block, and this pointer will increase basically. H will not increase, right? So I will come over here. So again, is this not equal to 0? Yes, it is not equal to 0. So what will happen? The value will be swapped, right? These value will be swapped. So how the array would look like: 1 1 0 2 5. Got it? So we'll have the indexes like this: 0 1 2 3 4, and the both the pointer would increase. So here we will have like H is here as of now, so it will come over here and I would come over here, right? Now again, this value like the I 2 is not equal to 0, again the swap will happen. So the array would look like this: 1 1 um, 2 0 5, right? And again, like H will also increase, I will also increase. So when there is a swap, then only H like helper is increasing. So this this is how it would look like. Again, at the last step, this value is not equal to 0, right? So again, swap will happen: 2, and we will have 5 and 0, right? And we will have helper over here, and I will come out of the array. And at the end, this would be our answer basically, right? So if we talk about the space complexity and time complexity, then space complexity is O of 1 because we are not using extra space. We are doing all these things in place, right? And the time complexity is O of n. Got it? So let me show you the code basically. So if you see here, the same thing we are using, the swap logic is simple, right? We are just swapping the value of I and the helper pointer, and that's it. Like, and other thing is same. I will explain you this, but before that, let me run this. So if you see all the values at the end of the uh, array, basically the non-zero values. So what this line is, so basically this is the swap using using the extra variable. So other way in Python we have is tuple unpacking. So basically we do in the single line without using any extra variable basically. So if we run this also, we will get the same answer. So this was the code for the case when we want non-zero value at the end of the array. What if we want the zero at the beginning of the array? So as we know, the helper pointer only moves when we have, like in the case when we want zero at the end of the array. So this only move when we have the non-zero values, right? So what we can do, we can just make this as equal to 0. So when it is equal to 0, then helper pointer will move, right? And if it is equal to 0 and we are swapping the 0 with the other variables, then what will happen? All the zeros would come at the beginning and non-zero value will go to the end of the array. So we just change this condition, right? And let me run this code. So now if you see, we have zeros at the beginning and the non-zero at the end of the array. Why? The simple logic, because helper is holding the values. uh, Basically, if we want the value at the beginning non-zero, then we are moving the helper at that point only, and the same way in the other condition, right? So yes, if you like this content, please do like, subscribe, and share the channel. I will like, I don't need to put this input thing, right? You can take any example and solve this problem. So let's meet in the next problem. Until then.